everyone. Last time we discussed cardiac cycle and heart sounds. This session will talk about the regulation of cardiac function. Here are the learning objectives today. After completing this session, you will be able to list the factors regulating venous return, compare various factors regulating cardiac output. Let's start with a case. Mr. Lin, a 68-year-old man, complains of increasing weakness and fatigue, worsening shortness of breath when he lies down flat on his back. He has to sleep with several pillows. Clinical findings include heart rate 130, blood pressure 90/60. He has peripheral cyanosis and rapid breathing, ascites, fluid in the abdomen, and swollen ankles. His ventricular ejection fraction is only 0.35. His past history includes chest pain and breathlessness on exertion. What are the underlying mechanisms for the clinical manifestations of Mr. Lin? You will find the answers when we finish our discussion today. The function of the heart is to pump blood into blood vessels that perfuse all parts of our body. Cardiac output is the amount of blood ejected by each ventricle in 1 minute. It is a product of stroke volume and heart rate. Stroke volume is defined as the volume of blood pumped out by each ventricle with each beat. In general, stroke volume is related to the force of ventricular contraction. When a healthy adult is at rest, the heart rate is about 75 per minute. In the stroke volume, roughly 70 milliliters per beat. So the average adult cardiac output is about 5 liters. As you can see, the entire blood volume passes through each side of the heart every minute. Please note that cardiac output varies directly with stroke volume and heart rate. This means that increases in stroke volume and heart rate result in a higher cardiac output, and decreases in stroke volume and heart rate will lower cardiac output. We'll discuss the regulation of cardiac output later. Cardiac output changes dramatically in response to special demands, such as when you run to catch a bus. Cardiac reserve refers to the difference between resting and maximal cardiac output. In a young, healthy adult, cardiac reserve is typically 4 to 5 times the resting value. This means cardiac output can reach 20 to 25 liters per minute when needed. During competition, an athlete's cardiac output may reach 35 liters per minute. Since cardiac output is the product of stroke volume and heart rate, anything that changes stroke volume and heart rate would alter cardiac output. First, let's see how stroke volume is regulated. Stroke volume is the difference between the volume of blood in the ventricle before contraction. That's the end diastolic volume, EDV, and the volume remaining in the ventricle after contraction, the end systolic volume, ESV. The EDV is determined by the duration and ventricular diastole and by venous pressure, and is normally about 120 milliliters. The ESV is determined by arterial blood pressure and the force of ventricular contraction. Although many factors affect stroke volume by altering EDV or ESV, the most important factors are preload, contractility, and afterload. Preload affects EDV, whereas contractility and afterload modify the ESV. EDV is determined by venous return, the amount of blood returning to the heart. Anything that increases the volume or speed of venous return, such as a slow heart rate or exercise, increases EDV and consequently contractile force and SV. Venous return is the amount of blood returning to the heart from all organs and tissues in our body. It is determined by respiration, muscle contraction, gravity, venous pressure, and sympathetic tone. Let's go through these factors quickly. Inspiration promotes venous return by creating more negative intrathoracic pressure. This is called respiratory pump. When skeletal muscle contracts, the veins running along the muscle are compressed and squeezed. The valve of the vein proximal to the contracting muscle is open, and blood is propelled towards the heart. During ventricular relaxation, the valve proximal to muscles closes and prevents the backflow of blood. The valve distal to the muscles opens and allows the blood to flow upwards. This is so-called the muscle pump. Gravity is another factor affecting venous return. When a person stands for a long period, blood tends to accumulate in the leg veins due to gravity. Therefore, the amount of blood returning to the heart decreases. Venous pressure also affects return. The pressure in the great veins is much lower than that in venules. This pressure gradient helps to draw blood back to the heart. This is the end of part 1. Thank you.